optics. So I'm going to draw in here. I would like to use a color that's not black, I guess red. So here we're kind of talking about refraction, and so I wanted to label these for you. I know we did it last time, but I want to label it again. This right here, this is your angle of incidence. And this right here is your angle of refraction. Okay, we call this right here in physics, we call this the normal, and it's just a perpendicular line. Okay, and then these are two different mediums. So for example, this could be air, and this could be water. When we travel into a more dense medium, basically almost anything is more dense than air, your angle is going to be refracted closer to the normal, and so this angle is going to be smaller than this one. They're not going to be the same. Okay. And then there's a formula for this, but they don't make you guys know the formula. When I taught in the face-to-face classroom, we actually did make them do the math for this, but they don't make you guys do this. And then each medium has what they call an index of refraction, and that's what this N is. That's called the index of refraction. And this is something that is particular to each medium. So like air has an index of refraction that is different from water, which is different from glass. And that's just what that N is. And if you were doing the math, which you guys aren't, you can just look it up. It's just a value that you'd look up or they would give you. The index of refraction for air is 1, and then all the others are usually more than that. Now, some objects actually have the same index of refraction. I think there's an example in your notes or in the test that talks about like a piece of glass or a piece of acrylic or something in corn oil. And those two things actually have the same index of refraction. So when you, let's say this is a big tub of corn oil, right? If you were to drop a piece of glass in here that has the same index of refraction, I'm going to do it in dotted lines here so you can actually tell. It actually looks like the glass disappears. And the reason for that is because they have the same index of refraction. And so the light doesn't bend between the two mediums because, you know, they're the exact same medium. And so the light just goes exactly the same straight through. And so the piece of glass actually just disappears in the corn oil. And that's because they have the same index of refraction. If you were to put something else in there that had a different index of refraction, you know, you'd be able to see it really easily because it has a different index of refraction, and so the light will refract. Total internal reflection is they use this. This explains why diamonds are so sparkly. And basically, it has to do with when you've got something like a diamond or something like that, and you've just got you've got all this reflection going on within the diamond. You know, the light's just going in and hitting itself and then going, and so it's causing all this sparkliness. Um, and that's basically what's going on with total internal reflection. Nothing's coming out, it's all sparkling in here, and that's causing that diamond to be so sparkly.